I think now you are comfortable with the you are comfortable or you are able to understand the programs.
Yes, ma'am.
Yeah. Now we'll little bit more complex programs. Let us see. Now, in the previous class, I started with one problem, that is one program, that is how to add the contents of. Okay, there are two operands. Those two operands, how to add it, we have discussed. Now the same program, let me expand in this way. This is program number which one? Program number 7. I'll share this complete notes with you. And today's date, eleven. Okay. Write a program. So program number 7. Write a program. Wherever you feel some difficulty in understanding the program, you can stop me at that point and you can ask me to explain. Okay, write a program to add value, add, or shall we go for how to add 10 numbers and then how to add 3 to 10 times? Okay, write a value, write a program to add value 3 to accumulator 10 times. This is a simple program. So what does that mean? Students, can you tell me if someone has understood this particular statement? You can tell me. You can explain me. What is the task supposed to be written? Or task the 8051 has to complete?
Ma'am, the same instruction of addition of
Make
3 has to be done 10 times to accumulate
Correct.
it.
Yeah, what the task has to be done at each time?
Looping, ma'am.
Looping, fine, but what is the task that's supposed to be done?
Ma'am, every
addition,
time
ma'am.
the 3 has to be added to the present content of accumulator.
Correct. But he has not told any what is the specific content on accumulator, right? As per the definition. Okay, now
Yes, ma'am.
you have to write a program to perform this task by the 8051. So for that, what is the first instruction that you can make use? First, let us discuss the task or the algorithm. In terms of algorithm, let me explain. So what is first statement? Write a ALP. So we need to write an assembly language program to perform the following task. Add a value of 3. So 3 value is equal to 3. 1 minute, man. Important call. I'll answer that to that and I'll call you. So here what we have to do, a value has to be considered, a specific value. It is very specific. What is that specific value? 3. So 3 is to be added to this particular value to be added. So add means it is in 8051 a plus sign. So arithmetic addition has to be used. And so when the addition operation has to be used, another important thing in the task, it is specified clearly. This value is constant value 3 has to be added to the accumulator only. Accumulator only. So therefore, so the task is very simple. A contents to be added with 3 and the result has to be stored with accumulator back. Is it clear?
Yes, ma'am.
Yeah, this task, how many times needs to be repeated? So this is the new content that is going to get on accumulator. So for this particular, this task, this is first time. Second time, same accumulator contents of the previous step has to be passed, and to this content, 3 value has to be added and the new value to be stored onto accumulator. In the third step, what it has to be done? New accumulator should be the previous step accumulator contents plus 03 and new value to be added to the accumulator back again. In the fourth step also, the previous step partial sum has to be taken as the content of accumulator and to which 3 needs to be added and the new result has to be stored back onto the accumulator. And fifth step is again accumulator contents, again the new accumulator content should be the older contents for which 3 you add it and take the new value. Sixth time when we are performing the old accumulator contents to which constant value 3 you add it and get the new value. Seventh step, same procedure you need to follow. Previous content, add it with accumulator old contents plus 03 new, get the new value 8 times, 9 times, 10 times. The same repetitive operation has to be followed. So accumulator contents plus 3. If you look at the all 10 steps, which is the task that is getting repeated? Yes, students, which is the task that is getting repeated?
Addition.
Addition instruction is getting repeated. Sorry. Okay. This has to be coming. Okay. Now, if you look at all these steps, in each step, the same operation has to be performed. How many times this addition, a constant value of 3 needs to be added? 10 times it has to be added. So what is the data that is going to be added? Here, let us be specific. Okay. So we require for addition requirements. Addition, what is the requirement? 2 operands are required, right? Out of these 2 operands, 1 operand, it is equal to what? What is 1 operand? The first, there are 2 operands to be added. If you look at here in
Accumulator contents.
1 operand to be fixed on accumulator. Second operand?
The value, ma'am.
The value. What is that value? It's equal to 3, right? This 3 has to be added. So therefore, since accumulator has to be the one of the must register to be used in the in the addition operation. So we'll fix this first operand which is holded by the accumulator as destination. The second operand I'll fix it as source. Is it clear? Is it clear?
Yes, ma'am.
Yeah. Now, what is the mnemonic that has to be added? Like this, you need to analyze each problem. Mnemonic. Which mnemonic for the arithmetic addition to perform in 8051?
ADD.
We have two instructions. Which are the two instructions? One is
ADD and
ADD and
ADDC.
ADDC.
A, D, D, C. Which one to be used now? The question arises. For the first step, suppose in the first step, accumulator I have fixed with FF plus 3 if I add, whether the carry will generate or not.
It will, ma'am.
It will. So that time, whether I have to go for, because next time if I add 3 to that result, again carry will be generated, again carry it is going to continue. So therefore my doubt is now whether to go for add instruction or ADD instruction, because we doesn't know what is the accumulator content here initially to start with. ADD or ADC?
ADDC, ma'am.
ADDC.
Yeah, why? Because let us be specific, even carry to consider along with the first step addition. Clear? So therefore now, which is the instruction we are going to make use to perform this operation? ADDC instruction. And we know the task that is supposed to be addition of two operands. One operand is an accumulator and the other operand is an immediate data ASH3. And how many times it has to be repeated? It has to be repeated for 10 times. Clear?
Yes, ma'am.
Okay,
Yes,
now
ma'am.
the algorithm I'll write. This is what the step-by-step task completion you can write it in that way. So let me write the algorithm, because the algorithm you can start now itself. Learning. Initialize. What is the first step? Initialize. To start with our program, what are the initializations we require? Initialize, program, and operands. Correct? Correct? Next, using assembler directive, you need to initialize the program and you have to define the operands also. That is what the initialization procedure. Then next step is let me give the program. Have I used the looping? Have I explained the looping for everyone? Because first batch students of lab, in that I have explained, but not for everyone. I think so. Did I explain for any program how to use DJNZ?
No, ma'am.
No. Okay.
Ma'am, in the lab you did, ma'am. For
Yeah,
batch
lab,
1.
okay, for one batch, but for the other batch I have not explained. No, let me write this program by explaining that particular DJNZ instruction so that students will be comfortable to use in the other use for the other programs. Okay. Now, after initializing the program and the operands definition, okay. Next, what I'll do, initialize the programs and the operands. Add accumulator with 3 along with carry. This is first step. Second step, the next step will be repeat the process. Repeat the process for how many times?
10 times.
For 10 times. Okay. Then terminate the program. Terminate the program. So this is what the actual algorithm you have to explain. Okay, now once we know the algorithm, let us start with program. ALP, that is assembly language program. So what is the first step of our algorithm? Initialize program. How do we initialize? Initialization assembler directive org 00h. If you want, you can write it as 200h, means our PC will point to, PC will be directed by the assembler to point to ROM space of how much? 200h. Okay. Next, after initialization, what is the next initialization we have to do? Operands. So in this, let me define a well-defined accumulator contents, because that we need to add it with a constant value of 3. So therefore, let me start with accumulator as 00h. Any value. If you want 0, you can add it. Otherwise, you can go for some other value also. Next. Okay. Addition instruction will be with #3. So what is now? ADDC instruction. I've planned to use it. So what I'll do, before I go for ADDC, clear C. What did this will do? This will clear the carry flag. Then use ADDC instruction. In this, source operand should be #3 and destination should be accumulator. So this is your destination and this is your source. Any doubt till this point?
No, ma'am.
No, ma'am.
Can I further continue? Okay. Now, once I added, how many times I've added this AD accumulator contents with 03?
Once, ma'am.
Once. How many times has to be repeated the same operation?
9 more times.
9 more times. ADDC with #3. But now, what is the content that is going to be considered in the second statement? Previous statements accumulator content will be the new content that is going to hold on this accumulator. So such instructions I'll be using, the same instruction I'll be using for 10 times. How many times I've added? So here,
10 times.
no, here in the program, how many times I've added? 1, no, 1, 2, 3,
6 times.
5, 6, right? So 7, 8, 9, 10. ADDC, this is 7th time I'm adding. ADDC, A, comma, #03h. This is #man. Don't get confused with, okay. 8th time is ADDC, A, comma, #03h. 9th time ADDC, A, comma, #03h. 10th time is ADDC A comma hash 03H. Have I completed the task? Yeah, 10 times to be added with accumulator 3.
Yes, ma'am. Completed.
Yeah, 8051 has been instructed to repeat this ADDC instruction for 10 times. Now, what is the next step? Task finished or not?
Yes, ma'am.
Yes, ma'am.
Task finished. So, you need to terminate the program. In the algorithm, the third step is terminating program. For that terminating program, so we will be using infinite looping instruction, that is sjump, short jump here. Here is a address. That address will be to the same instruction, so that indefinitely the processor will be continuing to execute this instruction, and the last statement will be the end statement. Okay, now let us come back to the analysis portion. Comments we need to take it, right? What is the accumulator contents at the first point? Okay, after compilation, it will check the syntax errors and no syntax errors. Execution command you will give, it will execute. Okay, now PC has pointed to 200 and move A comma hash 00H. So here accumulator contents will become 00H. Clear C means carry flag will become 0. Now ADDC A comma hash 3. What is accumulator contents and the next step? Here accumulator will be equal to accumulator contents plus 3
3H.
plus carry flag. What is carry flag?
0.
The accumulator 0 plus 3 plus 0. What is the result that is going to store on accumulator in the first step?
0.
Yeah?
03, ma'am.
3. Ma'am.
Yeah. In the second step, what is this already previous instruction which is taking the value on accumulator? What is its value?
03 plus A.
Yeah, very good. New accumulator will be equal to 3 plus 3 plus 0. So here it is going to be 6. In this step, accumulator will be equal to 6 plus 3 plus 0. Am I writing correctly?
Yes, ma'am.
Yes, ma'am.
So 6 plus 3, 9 plus 3 plus 0. What is the new content that is going to store onto the accumulator for the next step? 9 plus 3.
12, ma'am.
12 in hexadecimal, because 8051 will take that number in hexadecimal. What will be its value? Yeah? C. Correct? C plus 3 plus 0, because carry it has not been generated so far. Okay. So accumulator contents in this step, C plus 3. 12 plus 3 is 15. Yeah? 0F plus 3 plus 0. Okay. Now, what is this content? F plus 3.
012.
Very good. Accumulator will be equal to 1, 2, H plus 3 plus 0. Carry has not been generated. So that will be. Now at this point, accumulator will be equal to 15H plus 3 plus 0. So in the next step, accumulator contains 15 plus 3, 18H plus 3 plus 0. Okay, so now 18 plus 3, that will become how much?
1B, ma'am.
18 plus 3 is 1B. Yeah, 1BH plus 03 plus 0 will be the new content that is going to store. So what will be the last accumulator content? Last step accumulator content? 1B plus 3. 11.
1E, ma'am.
1EH, that will be the new accumulator content or sum you will get here in this particular program. Any difficulty in writing like this the program for a given task to finish its finish by 1851? So it is not that very difficult. But now then this is the one way of writing the program to perform this given task. Means adding a constant value 3 for 10 times to the accumulator through the repetitive add instruction. But is there any alternative method we have in order to write this program? Because code length, if you observe, same instruction in this particular program, you are repeating for 10 times. Is there any, this 10 times repetition of the same instruction, can we minimize it to 1? Yes, that is possible through looping. Here, alternate technique, instead of using this type of previous type of programming, alternate technique will be using. Alternate technique can be implemented. What is the advantage of this going for this alternate technique or thinking for the alternate technique? The reason is very simple. The code length, it is very huge if this type of programming it is adopted. Initially, when you are a programmer, when you are writing these simple programs or as a learner, when you are writing the programs, this will be fine. But as you are getting experienced with microcontroller, all instructions, this may not be the correct way of writing the programs in such cases, and that is the one reason why we'll go for alternate technique. The another reason is that when these many instructions are written, start writing in the code or in the program length may increase. Whenever the number of instructions, the program length is nothing but the program instructions. As program length increases, mean to say number of instructions increases, the memory occupied by this particular program in the ROM area also, which is going to increase. So how to avoid? Because whenever we are designing something, we have to go for the program length or program memory in an optimized way to use. So that will be a good programmer, good programming skill that a programmer will have. So therefore, to fulfill that satisfaction, we will be going for the alternative technique. In this alternative technique, looping will be implementing. Looping will be incorporated. So what do you mean by looping? Means any instruction when it is getting repeated more number of times, that we can repetitive instructions can be added in loop. So how that looping we will be going for means, again the algorithm I'll change. What is the algorithm first statement in the previous program? In the previous technique? Speak out. No, initialize the program, initialize the registers. algorithm I am telling. So here also you will have initialize program through org and initialize even the operands. Same. But since we are going for repetitive operation to minimize, we will be defining the counter. So the next step is initialize counter. Okay. After initializing the counter, add. Okay. Add accumulator with constant value 03H for the first time. Next step, decrement count and okay, and check whether count value equal to 0 or not. The condition now, the doubt which may arise for you is that if suppose count value is not equal to 0, then what should the controller has to do? And if count value goes to 0, what the controller has to do? So for this, if count is not equal to 0 after decrementation, go back to addition instruction. Very what is that? Very specific algorithm I am writing. I have not written the generalized algorithm. Okay. Go to the otherwise. Otherwise means what? Count becomes 0. Terminate the program. Otherwise, terminate the program. So this is the actual algorithm that we need to implement in the repetitive operations. Algorithm, is it clear, students?
Yes, ma'am.
Only two I can listen your understanding, but others, why I don't know what is their problem. Whether they are not serious about the classes, they are able to understand or not. Nothing I am able to get the clarity. If you are in an offline, then we will have one-to-one face interactions, but at least now orally you discuss, man. Okay. Now, otherwise terminate the program. Let me write now the program. If you have, what is the first step of our program? Initialize the program. So org is 200H. I'll retain as it is. The second one, initialize the operands. Move a comma hash 00H. Then move. What is that next statement supposed to be? What is that, man? In the first step after the operands initialization, clear C. Yeah. Second step of the algorithm says that initialize counter. So counter, let me take some register. How many times this counter will hold a value of how many times the add instruction to be repeated. How many times this add instruction has to be repeated?
10 times.
10 times. So therefore move R7 comma hash 0A I'll write. 10 in hexadecimal equivalent to 0A. So I have written 0A H. Next, I'll write the first instruction, that is ADDC A comma hash 03H. Right? So I have added first time, and next I have to decrement this R7. Once I've added, second time to add, I have to see whether R7 has reached 0 or not. So therefore what I'll be doing, one more instruction I'll use, DJNZ R7 comma back. So that back label, I'll write it to an instruction that is pointing to ADDC comma A comma hash 3. What this instruction will do means, this DJNZ, each time R7 contents will be decremented by 1. For the first time, decrement means what? Minus 1 will be subtracted. So what will be that content? Decrement R7. Initially, R7 value is 0A. Are you able to get it?
Yes, ma'am.
Yeah. After first time after adding, once added, the contents have been added. So R7 has to be decremented by 1. Once this R7 contents have been decremented, the new content that is going to store in this R7 will be 9. So is this 9 equal to 0? No. So jump is an program sequencing instruction. If not R7 contents, if not 0, jump back. Back is where it is written that label is written to the ADDC instruction. So now controller will go back to this address, and what is the instruction that is stored in that particular instruction? Sorry, in that address?
Excuse me, ma'am.
Yeah, Nisha.
Ma'am, this is after ADDC.
Huh.
The contents of A that is added to 03, no, ma'am, like A plus 03.
Correct. Plus carry.
And then it is decremented by 1, no, ma'am.
No. Accumulator we are not decrementing. Please look at the next instruction. Can you read out that next instruction?
No,
Yeah.
accumulator only, no, ma'am.
See, this accumulator contents is 03 with what is here the contents?
03H.
03H. Now, in the next instruction, so for that only I am asking one of the student can read second statement, that is next instruction. What is this?
R7.
DJNZ R7 means decrement. Which register? R7. R7 decrement means what? 1 will be subtracted, right?
09H.
Yeah, very good. So now this R7 contents, is it 0?
No, ma'am.
So therefore, decrement R7 contents, jump if R7 contents are not equal to 0. So where it has to jump back, it will jump back. Back is given to, back is an address. That address, it is connect, it is the address pointing to which instruction?
Add C.
ADDC instruction. So now again the controller will make the addition operation. Already accumulator has got 3. Again 3 will be added. It will become 9. So 2 times have been added. So decrement R7. Now R7 content will become what?
08H.
08. Is it equal to 0?
No, ma'am.
So it will go back, right? Controller is instructed to go back.
Yes,
so
ma'am.
again it adds. Again it checks for R7 content by decrementing. Now it will become 7, 6, 5, 4, 3, 2, 1. Okay. by the time 10 times the addition instruction will get executed. Okay, after decrementing R7, when R7 is at 1 value, when it is decremented, what will be R7 contents will be? What will be the R7 contents after decrementing R7 for 10 times?
0, ma'am.
0. So that time R7 contents, since will be equal to 0, this condition fails. So whenever this condition fails, because the condition to be satisfied to go back to this address is R7 content should not be 0. But here at the 10th time, this content will become 0. It will terminate the program. So whenever it will come out from this looping, the termination has to be done. Sjump here. Okay, 1 minute. Okay, the next instruction, it is sjump here, termination program. Okay, last statement is end. How many lines program we have written? 1, 2, 3, 4, 5, 6, 7, 8. 8 instructions. Whereas if you go for the previous program, you check it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 11, 12, 13, 14, 15. So 8 lines code, 15 lines code. So which is more optimized memory usage program?
Looping, ma'am.
Looping.
And you feel that it is very easy to adopt whenever there is a repetitive instruction which is getting repeated for n number of times. Only the extra thing you have to use is that the counter initialization and decrementing that counter and checking for whether its contents are equal to 0 or not. That's all you have to incorporate. Is it clear, students, how to incorporate this looping?